Hello friends, and welcome to yet another video in a series of videos where we discuss about previous year NEET JEE question paper. Today we will be analyzing a question which is taken from a chapter called Gravity, which was answered in JEE Advance question paper. Let this question be a revision for the students. At the same time, any students who are preparing for JEE and NEET for the next coming academic year can be very beneficial for them. So watch the video until the end. If you're new to my videos, please hit the subscribe button and the bell button so that you get all my notifications whenever I upload a new video for you. So without wasting any time, let's get started.
So let's analyze this question. Consider a spherical gaseous cloud of mass density, a rho of r in free space, where r is the radial distance from the center. That means density is a function of r. The gaseous cloud is made of particles of equal mass, small letter m, moving in a circular orbit around about the common center with the same kinetic energy. That means all the particles do have the same kinetic energy. The force acting on the particle is the mutual gravitational force. That is the point. Since it is a mutual gravitational force is a conservative force. So we can write down this equation for kinetic energy very fast. If rho of r is a constant in time, the particle number density, that means you have to find out density per unit masses, which are four options which are given here. One option is the right answer. So let's analyze this question. Density is given as a function of r. Okay, so if I draw this figure, you could have a figure like this. You will understand that it's a sphere, and the sphere, all the particles are rotating in the same direction. Obviously, it is an attraction make it to rotate in a same direction. Okay, now the particles are distributed and all the masses do have the same kinetic energy. So we can write down this equation for kinetic energy directly. Kinetic energy is equal to G capital M, the total mass of the sphere, multiplied by one of the mass to create the centripetal force, GMM divided by 2 times R. So from here we can analyze what is capital M. The capital M is equal to 2kr divided by G times small letter m. So if you write down this equation for mass is equal to density multiplied by volume. What's the equation for volume? Volume is 4 pi r square multiplied by dr. That means surface area multiplied by the length will give you the volume, multiplied by density is equal to 2kr divided by G times m. So obviously kr can be written as dr. So this dr and dr could cancel each other, and 2 and 4 could be cancelled, giving you k rho is equal to k divided by 2 pi r square m times g. But we have to find out density per unit mass. So what we are doing, we are dividing with its small letter m. So we are getting k divided by 2 pi r square m square times g. If you look at the four options, you will understand that the second option, k divided by 2 pi r square m square times g, is the right answer. We can also do the sum in a very almost in a similar way. We have already said that it's the gravitational force. Gravitational force of attraction keeps the mass rotating. So we can equate the equation with force as well. Gravitational force becomes equal to centripetal force. So what's the equation for gravitational force? Capital M small m divided by r square becomes equal to, yes, centripetal force is mv square divided by r. So from here itself we could cancel r and r. So we are not cancelling m. Why? Because we have to write kinetic energy. We're multiplying 2 in both the sides. You get capital G small m divided by 2 times r is equal to half mv square. This is the same method by which we derive the equation for kinetic energy from common conservative forces equations. So from here we can again proceed the same method. K we can write it here. The remaining is still the same thing, divided by 2r. The same method is followed the right hand side. Okay, I believe that you understood the question and the method of doing that sum properly.
If you like that video, please hit that like button and share with all your friends. With my next video, taking care. Bye.